Stop memorizing. Derive parallel resistance like a pro. Okay, let's dive into it. Here it is parallel circuit that we will derive our equivalent parallel resistance from. Okay, we know that in a parallel circuit, the voltage across the individual resistance is the same as the supply voltage. What do I mean? I mean that the voltage that cuts across this resistor R1 is the same as the supply voltage. So with that statement, I can write that V, which is the supply voltage, is equal to what? The voltage across the individual resistance will be equal to V1, it will be equal to V2, and equals to what? V3. So we can call this equation 1. Also, we know that one of the characteristics of a parallel circuit when it comes to current, the current through the individual resistor is different from the supply current. What do I mean? I mean that the current in a parallel circuit differs. With that statement, I can write that the supply current, which is I, is equal to what? I1 plus I2 plus I3. We can call this equation, we can call that equation 2. What is our aim? Our aim is to derive the equivalent resistance of a parallel circuit. But I said that in a parallel circuit, the current differs. So what we are going to do here, we are going to look for this value of current that differs. And also we will look for this value of I1, which is the current that differs. Then after we have gotten the value of the current that differs, we will not substitute it into equation 2. So for I, but we know that from Ohm's law, V is equal to what? I R. Let me put this from Ohm's law. From what? Ohm's law. We will now look for this value of what? Current, which is I. So from Ohm's law, we will make I the subject of the formula, which it will be V is equal to what? I R. I just brought the Ohm's law equation down. So making I the subject of the formula, we will divide both sides by R. So we will divide here by R, divide here by R. This will take away this. So therefore, I is now equals to what? V all over R. So let's make it R equivalent. The equivalent resistance R equivalent. That is for I. Then the value of I1 that differs in the circuit with respect to this, we can say that I1 it will be equals to V all over what? R1 with respect to this, with respect to Ohm's law. Also, the value of I2 that differs in the circuit will be I2 with respect to Ohm's law. It will be what? V all over what? R2. And the value of I3 that differs will be I3 will be equals to V all over R3. So we call this entire equation, both I, we call this equation 3. We call this equation 3. So what are we going to do now? Since we have gotten the value of current that differs, we will now substitute this current into equation 2 so that we can be able to get our equivalent resistance. So let me bring down equation 2. We have that I equals to I1 plus I2 plus I3. That is the equation 2. So we will now substitute the value of the current that differs into equation 2. We have that for I, we have that I is equals to V all over R equivalent. So it will be V all over R equivalent, which is equals to I1 will be V all over R1 plus I2 will be V all over R2 plus I3 will be V all over R3. Something is common here. V is common. So we will factorize V in this equation. So this is the same thing as V all over 1 all over R equivalent equals to V is common here. So we will factorize V, which will be V into bracket 1 all over R1 plus 1 all over R2 plus 1 all over R3. So from here, for us to make R equivalent the subject of the formula, we can divide both sides by the coefficients of what? 1 over R equivalent. Or we can cancel this V, can cancel this V. So any of them, we will still get the same result. If we should divide both sides by V, we will still have this same result. So the answer will be equals to 1 all over R equivalent will be equals to 1 all over R1 plus 1 all over R2 plus 1 all over R3. So therefore, for any value of resistor or resistance in a circuit, we will have that the equivalent resistance of a parallel circuit will be equals to 1 all over R equivalent. R equivalent is equals to 1 all over R1 plus 1 all over R2 plus 1 all over R3 plus any value of resistor 1 all over R and any values of what? Resistor. If we are given 7 values of resistor, you can still write it towards 1 all over R4 to 1 all over what? R7. That is the meaning of this Rn, which is to any number of what? Resistor. Bye.